All right, so we've been working the past few days on condensing and expanding logarithmic expressions, and that's going to be necessary for actually starting to solve them, and that's what we're going to be doing today. Today we're really going to focus in on actually solving logarithmic equations. Now, if I'm going to solve a logarithmic equation, normally the first step is to actually condense it, right? Because we want to make this as simple as possible. So our first step should always be to condense into single log. And in parentheses there, I'm going to put if necessary, because if there's only one log, then there's no condensing needed. But if there's multiple logs, you will probably need to condense. So I'm going to kind of do this as we do number one and step through it. So if we look at number one, right, here's my equal sign. That means I need to put everything together on this side. And luckily, I can put these two together right now because they have the same base. Remember, you can only combine logs if they have the same base. And in this case, there's addition between it. So addition really means that we're going to have to multiply to combine them. So really, I'm doing log base 2 of x minus 2 times x plus 2. Well, so remember, when I multiply these ones, since they're binomials, we have to distribute, right? So we'd get x squared, and then plus 2x minus 2x, and then negative 2 times positive 2 is negative 4, and of course those would cancel out. So now I have log base 2 of x squared minus 4 minus 2 equals 1. So now when I'm looking at this, the idea is I can't really put these together because this is a log and this is not. So after I get into one log, the idea is I'm going to actually have to isolate the log. So step 2 is to isolate log using addition or subtraction. Okay, so I can get rid of this 2 by adding it to either side. So we add 2. So now our new equation is log base 2 of x squared minus 4 equals 3. Now, the issue that I see is if I'm going to solve for x, x is actually inside the log. So if I want to solve for x, I need to get it out of the log. So if I'm trying to get it out of the log, the idea is you're going to need to change it to its other format so you can get the variable out of the log. So in this case, we're going to need to change from log to exponential form. Because if I want to get a variable out of the log, we need to change it into exponential. So remember that whole idea of the base to the exponent equals the answer, right? So that'd be 2 to the third power equals x squared minus 4. Now, this is something that we can actually go ahead and solve. So that's my next step, is just to solve for x, or whatever the variable happens to be. So we would add 4, right? Well, I should probably cube this first. So 2 to the third power is 8. And then when we add 4 to that, we end up with 12. So we have 12 equals x squared. And now we can square root it, right? So remember, since this is an even root, right? Even root means that this has a positive and negative answer. So this would split up into square root 4, square root 3. The square root of 4 is 2. Square root of 3, and it's positive or negative because we took an even root. Now, your last step, and this step is very important and one that most people forget, is to check for extraneous solutions. Oops, that's an S. And what you should really know about this is that the logs cannot be negative. So if I plug this back in and we get a negative in there, then that does not work. So in this case, we would be taking negative 2 root 3 and putting this into here. So we would have negative 2 root 3 minus 2, which would mean I would have a negative inside of there, right? Because a negative and a negative, we're going to get a negative, which tells me the negative is extraneous, so I cannot have that negative. So 2 root 3 should be, let's check and see, but 2 minus 2 would be positive because 2 root 3 is a little bit more than 2, and 2 plus 2 is going to be positive. So your final answer is only the 2 root 3 because you need to plug it back in and see if you would end up getting an extraneous solution or not. All right, so we're going to do one more of these together before you try it on your own. Let's try looking at number 2 together, and then number 3 you're going to try on your own, and 4 you're going to try on your own. Okay? But for number 2, the nice thing about number 2 is that there's only one log, so there's no need to combine things together, right? So instead, what we can do is we can just go ahead and start isolating the variable. So remember, this would work the same way as always. Get rid of anything being added or subtracted first. So then we'd have 9 log base 10 of x equals 18, right? Now we could go ahead and put this in as an exponent, but I think right now, since it's multiplication here between them, the easiest thing to do is divide because 9 goes into 18 evenly. So we have log base 10 of x equals 2. And now again, we have our variable in the actual log. So if our variable is in the log, we're going to go ahead and change that to the exponential format. So the base to the exponent equals the answer. So it'd be 10 to the second power equals x. Well, 10 to the second power is 100, so x equals 100. And then we should plug it back in, but that would be a positive log, so I know that that works. So x equals 100 is our final answer. Okay, so I want you to go ahead and try the last 2 on your own, and we'll go over them in class. All right, now so that's probably the simplest way that we would have to solve for logs. Now, sometimes you're going to have to solve for logs with them being on different sides. So when you have logs on different sides, it's going to work slightly differently. So let's take a minute and look at what happens there. Well, the idea is if my logs are on opposite sides, that's not going to really work for me most of the time unless we can get the same logs on the same side. So logs with the same base being on different sides. That whole same base is going to be important because if they're the same base, it's actually a lot easier than if they're different bases. So our first step when doing these, just like it was before, is going to be to condense to a single log term on each side. Okay, so in this case, here's my equal sign, so I need to put these together so that I only have one log over here, but I already only have one log on this side. So these have the same base, so it's going to be okay if we put them together. And remember, with subtraction, that actually means we're going to divide to put them together. So we would have log base 2 of x plus 1 over x minus 1. All right, on the other side, there's nothing to condense, so we'll just leave that the way it is. Now, the nice thing about this is, since these are logs, they're both logs with a base of 2, if I want these to be equivalent to each other, wouldn't the insides just have to be equivalent? Because already we're taking log base 2 for both of them. So this is kind of like the exponential thing, right? If we're doing 4 to the third power, then and 4 to some other power, they both have to be 3. So if we're doing that here, since log base 2, it would have to be of the same thing to be equal. So we can just say x plus 1 over x minus 1 has to equal 5. Essentially what you're doing is you kind of cancel the log or the ln if they're both natural logs, if both sides have same base. Okay, now really we're just trying to say what would have to be in here so that the insides would be equal, because the outsides are already equal to each other. So it is kind of canceling, but in a way it's really not as well. But for simplicity's sake, we'll consider it to be canceling. Once you do that, then you're going to go ahead and you are going to solve for the variable. It could be x, y, z, whatever the variable is. In this case, when I look at it, I've got a fraction here, which makes it more complicated. So personally, I like to make this side a fraction and then just cross multiply to solve. So we're doing 5 times x minus 1 equals 1 times x minus 1. Okay, so now we can go ahead and we can distribute in, and we would end up with 5x minus 5 equals x minus 1. Then we can go ahead and subtract that x to move it to the other side. So we end up with 4x minus 5 equals negative 1. Then we can go ahead and add the 5 to the other side. So we have 4x equals 4, and divide by 4 to get x equals 1. And I would always double check for extraneous solutions. All right, so last step is to check for extraneous solutions. They're only extraneous if they make the log negative. So if I put a 1 into here, 1 plus 1 would be 2. That's positive. 1 minus 1 is 0. It's not negative, so we're good. So then my answer really is just the 1. All right, so we're going to do the next one together as well, because I feel like it is slightly more complicated than that one. So when I look at number 2, right, we have, here's our equal sign, so we have to combine these logs together first. Because they have the same base, we're okay, which means adding means to really multiply. So we're going to be multiplying x minus 2 times x plus 3, which would give me x squared plus 3x minus 2x minus 6, and combined our like terms, so we'd have x squared plus x minus 6, and it's log base 4 of all of this, equals, and then we need to do that same thing over here. They still, again, they have the same base, so we can go ahead and multiply them because it's addition between. So x plus 1 times x minus 1 would be x squared minus 1x plus 1x minus 1. So these would cancel. So we'd have log base 4 of x squared minus 1. Now again, when I look at this, right, log base 4, so we can just ignore that. And we have x squared plus x minus 6 equals x squared minus 1. Now this might look confusing at first, but again, we should be just trying to get all of our x's together. So I would go ahead and subtract this x squared to move it to the other side. Well, 1 minus 1, these cancel out, leaving me with x minus 6 equals negative 1. And then we can add the 6 to the other side. So we get x equals 5. And when we check it, 5 minus 2 is 3, so that's positive. 5 plus 3 is 8, so that's fine. 5 plus 1 is 6, so we get a positive log in there. 5 minus 1 is 4, positive log again. So we've checked to make sure there isn't an extraneous solution, so we're good with that. Okay, and you'll have to watch the next video for the last instructions.